All right, where were we before? We were looking at this hard example, and what makes coming up with tests hard for you is that if even you guys, if you were to see my solution, you would say, yeah, that's easy. And I look at my solution, I think it's really easy, right? Because I've been doing it for a long time. But coming up with the solution can be hard, right? And especially, during a panic of an exam, it's hard, right? And so in some ways, what I'm going to tell you now is exactly how you should come up with a solution, right? If you have some insight into what this means, and you can just have enough experience to kind of gestalt understand the whole thing at once and write down the proof, that would be great. But I'm not expecting that of you, right? So what you should do instead is not panic, not drown, and start brute forcing it, right? Brute force means just you have some tools and you throw your tools at the problem randomly, right? In a brute force sort of way. You might know the expression, if all you have in the world is a hammer, then everything looks like a nail, right? If you heard that expression, right? All right, so we're going to have in fact, my first 1019 question on an exam, I thought was really easy because I even listed which rules to use. I said, use them in this order, right? So then I'm thinking, it's really easy. I give you a bunch of axioms. I tell you, use this rule. Well, there was only one way to use the rule. And I say, use this rule. Well, there was only one way to use it. And I list these rules in an order. And if you just did them, then the answer falls out. And they're smirking because they probably didn't get it. Or maybe they did get it. Anyway, they're smirking. Right? So that's what I'd hope. And very few people got it, right? Very few. And half the class dropped out of the course. So in fact, let me tell you right now, we will work together. If you keep working, we'll work together. Don't drop out of the course. All right. So anyway, this says you can try to understand it. And if you can understand it, use brute force. And what do I mean by brute force? Well, these yellow dots over here are the sentences that are the axioms, right? These are the things that you know are true already. And we have a bunch of rules, like the hammer rule, right? Or whatever. So you just brute force. Usually most rules take two sentences. If alpha is true and alpha implies beta, then you know beta, right? In fact, if you have a list of axioms that I give you, and one of them is alpha, and one of them is alpha implies beta, dude, the first thing you do is Modus Ponens? First thing you do is Modus Ponens, and you get beta's true. What's that? That's no thinking. That's just brute force, right? You just maybe in the end you'll get the proof, and you'll never use the fact that beta was true, right? Maybe you'll prove things if you're brute forcing it. You might prove things that you never use. But that's okay. It'll make it a little longer for the marker to read, but they'll get over it. Right? All right. So you look at pairs of axioms and you look at rules, right? There's only so many things over here, so there's only so many pairs. There's only so many rules. You just try all combinations and you say, can I apply this rule here? And if you can apply it, apply it. And so then you say, what can I do? What does it produce? So there's all our rules, right? You'll see it doesn't say simplify here because I didn't update that. And then you say, oh, look it. From those two, I can get this. This is alpha, and this is alpha implies beta. I can get beta. And so you just keep banging out, right? And you'll note here that there's a depth to this because we couldn't have we can't use this rule until we produce this and we produce this, right? But you're just producing things. And from what I've produced, what more can I produce? What more can I produce? And you keep doing it, and hopefully you just accidentally bang into what we're trying to prove, right? And if you're out in the real world, maybe it would be, you're hoping for a lot to bang into what we want to prove, no guidance. But here, I'm being very selective on what I put over here, right? I'm trying to give you a problem that's easy without considering it easy, right? So I know this is short brute force proof, right? So it's not like banging over there is going to be a big miracle, right? I'm designing it that way. Right? Everybody see that? All right. So, so that's what we do. Right. So, so this is going the other direction. All right. Maybe you get that, you get all the way over there and you're happy, but maybe you don't. Right. So you're brute forcing it forward and you get kind of stuck. So another option is I've told you what you want to prove. Right? There's a sentence you want to prove. So you can start working backwards. And one thing that's confusing when I read people's thing is what I hate is when they repeat the question, right? I tell you, prove this. And then the first thing they write down is what they want to prove, right? And the reason I hate that is because, one, I don't want to read it a million times to reread the question. But also, if you write it as a statement, I don't know whether you're saying, this is what I want to prove, or this is what I have proved, right? You start by writing down a sentence. I think it's something that you claim is true. And no, I say, no, that's what you're supposed to prove. So how have you proved it? So don't start. What I often will do is I'll write it down on the bottom of the paper, right? On the top of the paper, top left of the paper, write down the things that you know are true, right? In the bottom right-hand corner, write down the thing that you need to be true. And then brute force this way and brute force this way. You know what I'm saying? And then I'll know if it's down here that you're implying this is my conclusion, right? And I'll tell you right now, if I'm marking at least, and I see that you start with these and you brute force, and you were here and you back, and then you didn't quite link them up, and you could hope I just don't notice that you didn't link them up, and then I'm less impressed because I think you're lying to me. But if you then put here, oops, I didn't know how to link them up, then you're being honest with me, and I'll be like, hey, well done, you did this and you did this. You observed that you didn't know how to link them together, and you'll get a lot of marks, especially when the rest of the class is crashing and burning, right? So what are we doing here? We're kind of going backwards. We're saying over here before, see how I divided this table into using versus proving, right? The using says, if I know this, what can I get from it? This is designed to be brute force forwards, right? And this is designed to be brute force backwards. If I know this already, how do I get this and? Well, I get it from this. How do I get, right? How do I get these, right? So you can say, how do I get that? Well, maybe this is this statement is alpha and beta, right? Well, you know right away, if you need to prove alpha and beta, chances are you're going to have to prove alpha and you're going to have to prove beta, right? So you can brute force it backwards. It's saying, I need alpha and beta, hence I need alpha and I need beta, right? And now you have two goals. This is saying, if you want to get here, it's not like walking where it's sufficient to go here or here. You have to go to both of them, right? So you have to remember that this is an and. You have to prove both of these, right? And so then you can keep kind of brute forcing back, right? Does that make sense? Now, this is where we left last class. And remember, I told you that it's useful to have some intuition about the problem, right? And intuition, this is where intuition comes. George says intuition is no good. Well, I don't know how he comes up with proofs then, right? Oh, so I started telling you the story that when I was a PhD student, my advisor, the way she proved things was she just, I know this is true, I know this is true, brute forward, right? And somehow I would go to sleep and I would wake up with this vision from the fairy godmothers of the universe of something that I needed to prove, right? So that's what this is. It's some statement in the middle, right? And what's magical about this statement is that my intuition or my fairy godmother, my subconscious, tells me that I think I can prove this from the axioms. And it also tells me I think I can get the conclusion from it, right? It tells me like it's helpful if it's not only sufficient to do it, but if you have some sense it's necessary, right? It's something I need to understand this inner problem, right? And my advisor might say, well, where did you get that from? I don't know. It just feels right, right? And then that helps you because it helps you build the link between these, right? Does that make sense? Right? And this is just saying, in the problem, any problem you're going to see in this course, there's only going to be so many things to try. So if you brute force it, then you'll be fine. All right. Actually, here's another story. If you like stories, so when I was 12, my sister was 16 and was in high school and learning those triangle things, right? You have this angle and you have this angle and you have to learn this angle, right? And my father is a famous mathematician, and we all know never to go him with math questions. But somehow he came upon these things where you have to prove this angle, and he was just unable to prove them. And it was because he was trying to get the intuition, and he was unwilling to do a brute force, right? Well, I was only 12, and I looked at the rules, and I just brute forced it, and I could solve them. And the key is that the ones that they gave you in high school were small enough that you could just brute force. You just say, I don't care what I'm trying to prove. I know these angles. What rule can I apply to get more information? Right? You just get more information and brute force it to stumble on the answer. All right. Oh, and this says, right, maybe not during a test because you don't have time, but in your, if you have time, you can make a really slick proof by this is what your brute force looks like, right? And then you have time to erase stuff, so you just have a nice clean proof. And you might say, what's the advantage of going from this to this? Is because if I'm marking and I get wrong answer, and suddenly there's the most perfect, brilliant answer I've ever seen in my entire life, and the question's only out of 10, I've been known to give people 12. It's like, you made my day. So, really, if you can get that perfect question, go for it. All right? All right, everybody good? All right, so how can you get cool things to prove? Well, we had that purple table of things to prove. And one thing you can do is say, how can I prove one of them from the others, right? What's the smallest list of things that you know are true in which you can prove the others? And when I was trying to come up, well, I was making up these purple tables, and I was trying to say which ones do you need, or which ones can you prove from other ones? And even if I can prove it from other ones, it seems useful enough to throw it in the table. But in the playing with it, I came up with these various questions. And here's this question is, suppose I only give you these guys. So these are the only ones you have. And I want you to proof by cases. All right? So that's our task, is the yellow dots on the left are the guys in the top box. And the green guy on the right that we're trying to prove is the guy in the is the bottom box, right? Everybody see what we're trying to do, right? So we're basically doing a big implies. If all of these are true, you assume all of these are true, then you get that this is true, right? All right. And yeah, why am I covering this one? Because it took me a little while, and I have another rule of thumb. If it takes me 10 minutes to solve a problem, it's too hard for you, right? I mean, because I have been doing it a long time. So this one took me a while, and we're going to try it, right? And what am I saying here? Well, you know, this rule, you can plug into any alpha here, right? So we're a little confused that this alpha, those alphas can be different. So just to make our life a little easier, let's change the names of the guys in the bottom. All right, that's just a name change. Let's first do intuition, right? If we think intuition, remember what this says is that there are two cases. Either this is actually makes our life harder because you have to remember that this is a mu, but it sounds like u, so that's okay. Whenever I say mu, you can think it's mu. And this one here is an omega. It's a baby in omega. There's capital omegas. But anyway, so you know one of these is true, and you don't know which, right? But there are two cases. And if the first one's true, you get what you want. And if the second one's true, you get what you want. All right? And you want to prove that given all of that, you get what you want, right? So that's what we want to prove, right? And so here we're saying, suppose you know these already, right? All right, so what I'm doing here actually is it's kind of a combination of backwards proving and forward proving, right? So when I first see this, what I'm proving, it implies, right? It's if the stuff on the left is true, then the stuff on the right is true. So I automatically know that if I'm going to prove that, I have to prove it using the technique of assume the stuff on the left is true, right? And then we'll go about and prove the stuff on the right, right? So here, those are the things that I'm assuming to be true, right? And those are the rules that I have to work with. And what do I have to conclude? I have to conclude phi. You have to remember what these letters are. I think that's the phi we're including, right? Everybody see that? So it's a little better than we have to prove this whole thing, right? We're assuming this, and over here we have one here. Over here we're going to have phi. All right, so now we're kind of brute forcing, and it's hard to see what we can do here, right? There's nothing that's clear, no rule, that's, but the only thing we can do, in fact, there's only one rule that applies at all, is that we can do contrapositives, right? So it's the only thing we know how to do. So let's do it. Maybe it's useful, right? And so what does this say? It says, did I actually apply it correctly? No, I didn't actually apply it correctly. We have to bring in the double negation. So really what you have to do is you have to say from this, I can add double negations, right? And then, right, because this has the negations on this side, and then I can come up to here, right? People see what I'm saying? Officially, that's what you have to do, but I told you we never have to do that. So let's assume that's an if and only if, and we can go ahead. Right? Right. So we got that, and we still don't know how useful it is. Right? In fact, I'm kind of abandoning ship on it because it just didn't feel like useful. All right. So then this one says, if I have the or and I know one of them's not true, then I can get the other. Right? I have an or, but I don't know. I don't have one of them's not true. So let's stick in here, and I'm going to say I need it, right? If I can prove that one of them's not true, then I get what I want, right? I get omega. I get the other one's true, right? And now what do I do? If I prove force from here, what rules do we apply? Yeah. Everybody should see this, guys. I got omega, and I got omega implies gamma or phi, whatever that is. What is that? Is that a phi? Let's call it phi, right? So obviously, you just you have to use Modus Ponens, right? So that gives us right what we want, and right. So you assume that, right, we get what we want. And this is kind of what this is where the intuition for this proof by cases comes, right? You know one of them's true. Now, what would be the worst case is one of them's not true, right? If by magic you can get one of them's not true, well, then our rules easily give us what we want, right? But are we done? No, because we don't have that it's not true. In fact, you could say, well, what do we need to use to prove this? You could say, I know what we need. We need proof by cases, right? Which is exactly what we're trying to prove, right? So we can't use proof by cases, proof by cases. Everybody see what we're doing here? All right. So anyway, what we did prove, right, is if we do deduction, we assume if we assume this and we got that, right? So we managed to prove a new statement that if mu is not true, we get what I want, right? Which actually feels like, if mu is not true, I get what we want. So it feels like an improvement, right? And that gets rid of the mu, and we can send, right? Now what we have, we got rid of the mu, and that's kind of nice. Now we know that if mu is true, we get what we want. If mu is not true, what we get what we want, right? So we got something that still feels like we should be able to prove it, right? But it's still proof by cases, right? Are we closer? Maybe we're closer. Maybe we're not closer. It's just a different form of proof by cases. Are people following what we're doing here? I'm just kind of trying to use some intuition and banging out our rules to see what we can get. Any questions? All right. So at this point, I felt, first off, when I'm doing it, I don't even know, can you get this from all of those, right? So I didn't even know if it was possible. My feeling was that those are pretty powerful rules and you should be able to prove everything from them. So I thought we could get there. Anyway, my feeling was, well, we haven't really made too much progress. So let's start over. All right. All right, we're back here. And now what we're going to do is we're going to try to work backwards. All right. So this tells me, what rule can I use? Well, suppose here I'm saying, what should my last rule be? And maybe my last rule would be Modus Ponens, right? So it says there's some pi, and if I could prove that pi, And separately, I could prove that pi gives me phi, then I'll be done, right? Here I'm just banging it out, seeing what I can do. And so that now I have, but I don't even know what pi should be, right? So this is where your intuition comes in, right? What do I think would be a good pi, right? And so I don't know, what are we doing here? I'm just sort of banging things out. Here we can flip this around, right? Not phi gives me not pi. Why did I do this? Just brute forcing it. It gives me other things to look for, right? And now how would we prove this? Well, we can do deduction, right? If I want, how do I prove this? Well, I prove it by you assume the left-hand side and you try to prove the right-hand side, right? So to do that, I'm going to start a proof of this, and I start a proof of this is by assuming not phi. Now, do I know not phi? No, and I don't need to know not phi. All I need to do is prove from not phi. I need to prove things, right? And all right, so what can I get from, right? And this proves, actually, this is starting to prove like a proof by contradiction, right? I want to prove pi. I want to prove phi, so I assume not phi. I try to get a contradiction, right? And I've told you already I don't like proof by contradiction, but maybe we need it here. All right, so what can we get from that? Well, if we have not phi, right, then we can do modus ponens. I mean, we can contrapositive and modus ponens to get us those two things, right? People say, this gives me knowing this gives me some power, right? And what you want is you want to be able to move. In fact, when I was working on a research problem, I know I'm not going to solve it in a day. All I want is every day to come up with some new idea, right? It doesn't have to be a good idea, but it just has to be a new idea, right? So here's a new idea. All right, and now I know two things, right? What do I do with two things? You add them, right? In fact, this case, I'm going to say, well, this is the negation of the and, right? Not the negation, the contrapositive of the and. It's the negation of the or. Everybody remember that I could have said not mu and not omega, but then you bring the negation out and you get mu or omega. All right. So that's what we did there. All right. All right. So now we have that this proves that, right? That's pretty good. So what should we say? Right? Can we get what should our pi be? Anybody have an insight what my pi should be? What? Yeah, right? Here I want to prove not pi. So I can make mu or omega my pi and we'll get what we want, right? Here I just define what pi is. And are we happy? What do we have to do? We also have to prove pi, right? And have we proved pi? Yeah, look at, and we're done. Everybody see that? And right, is that a good proof? Yeah, let's try to write it up. All right. Now, let me just again tell you that there's no way I would put something that was this hard on the test, because it took me a long time to prove it, right? But here, right? So we're trying to prove this. So we start off with a deduction proof. We say, right, our goal. Here, what am I? Sorry. Here I'm starting off with remember we leaped in the middle and we said, hey, this is the middle which I want to prove, right? So somehow I'm going to prove not gamma gives me this not pi, right? And so how do I prove that? Well, I assume the not gamma, and then I have my rules, right? Here I have these three things, and so these three rules, then I do contrapositive on them, right? And then I do modus ponens, and then I build, and I get what we want, right? Everybody see that? Right? And so now I've managed to prove, and then I have this thing, right? Remember what we did then is we ended with a contrapositive in it, right? We had right? So we switched. Now we had this statement, here, and we flipped it around. And this looks nice because it's of the form pi gives me what we want, right? And then we look up top and say, oh, how can we get pi? Oh, look at pi's in the list, right? Pi's in the list, so bang, we get gamma, right? Everybody good with that? Right? And so you can kind of see what I mean. If I gave you this as a solution, you might say, oh, yeah, I can follow this. But actually, if I were to read this as a solution, I would say, yeah, it looks hard to me, right? And the reason it looks hard to me is that there were some miracles that you had to do in here, right? The biggest miracle was starting here, right? We started in the middle, and we sort of joined the two together, right? So I am going to give you questions on the test, but they will all be what you should be doing is you're saying, if what you're trying to prove is left side gives me right side, then you start by assuming the left side, right? And you're trying to prove the right side, right? So what are we doing there? We're saying, this is what I want. What will be my last rule, right? My last rule will be deduction, right? And then you work, what do I know? How do you prove forces? You go forwards, right? And if you do a combination of those and you hack on it, my fantasy is that you can all do it. All right? And do you believe me? I'm not sure I believe me. So you're a fool to believe me. All right.